In this video, I'll do an example of adding vectors graphically. I have three vectors, b, c, and d. b is 4.12 as magnitude, 14 degrees clockwise of the positive x-axis. Vector c has a magnitude of 3 and points along the negative y-axis. Vector d has a magnitude of 5 and points 36.9 degrees counterclockwise of the negative x-axis. And I want to find this resulting h vector 3 times b plus 2 times d minus 4 times c. Really big pictures so you can work out all the angles is important. And so before I did that, I in fact sketched this out of where I thought it might end up. Without doing any calculations, I determined that most of the picture would be in this quadrant. If this is positive x, this is positive y. So the first thing is to get 3b plus 2d. So b is 14 degrees clockwise of the positive x-axis. Now I'm going to add to that twice the d vector, which is 36.9 degrees counterclockwise. But I need to do it using the tail to tip method. I'm going to draw a set of coordinates parallel to my x and y that are at the tip of b. So then I can put the tail of d there, and it's going to be off in this direction, where this angle from the negative x-axis is phi, and phi is 36.9 degrees. So I want to find the resulting vector of 3b plus 2d before I add a negative 4c to it. I'll just call this a. This vector a, so it's going to have a length a, and this has a length of 2d. This has a length of 3b. 3b is equal to 12.36, and 2d has a length of 10. I don't know exactly what these lengths are. I just sort of drew them freehand, but given that 12 is greater than 10 and that it is at a shallower angle, the 3b vector is a shallower angle than 2d, I know that when it comes back it doesn't cross the y-axis, so my proportions are at least roughly correct. And that can be important to be able to calculate your angles correctly, to get your picture roughly correct. So using the law of cosines, I can now find the length of vector a. Using the basic geometry rules, I know that this angle is also theta. That means this interior angle to this triangle is theta plus phi, and theta plus phi is equal to 50.9 degrees. Well, I have the law of cosines because I know these two sides, this interior angle, I can find a. A squared is equal to 3b squared plus 2d squared minus 2 times 3b times 2d times cosine of the angle opposite a, which is 50.9. I put that into my calculator, and I find that I have a value of a equal to 9.842. Give me some more digits there so I don't have rounding problems in the future. So I have a magnitude, and maybe I have to find the angle, but I'm going to go ahead and to see which angles I need, I'm going to go ahead and add 4c to that, and I can always come back to this triangle. So c points in the negative y. The minus sign flips that direction, so that's a magnitude of 3 in the positive y, and it's times 4, so I'm adding to this, to these two vectors, a vector of length 12 in the positive y direction. Well, I think that's going to be up here. It's going to be, again, if I sort of rough guess this out, 12 is going to cross the positive x-axis. It's going to be on the other side. So I need to find this vector here, and that is going to have a magnitude of h. This is my final vector. I need to find that length, which means I need to find this angle, which I will call alpha. Well, I know this angle here because this is a right triangle, and I know phi, so this angle is 90 minus phi. If I knew this total angle in here, I could take this angle minus, I'll call this angle gamma. This total angle is gamma. Alpha is going to be equal to gamma, that total angle, minus this interior angle, which is 90 minus phi. And I can find gamma now using the law of sines. So the law of sines tells me that sine of gamma divided by the length opposite it, which is 12.36, is equal to the sine of another angle that I know, 50.9, divided by the side opposite it, which is 9.842. And when I put this in the calculator, I got an angle of gamma, which is equal to 77.0566. So, but the problem is the law of sines is dual valued for angles between 0 and 180. So I don't know for sure if it's 77.056. If I graph the sine function, it looks like that between 0 and 180. So there are two values on symmetrically on either side of the 90-degree angle. So this could be 77, or it could be 103. 77 is 13 degrees less than 90, 103 is 13 degrees greater than 90, so it could be either of those values. I believe gamma is 77 from my picture, and so that gives me a value of alpha that's equal to 23.96 degrees when I calculate that from here. I've cleaned up my workspace a little bit, and so now I'm looking at this triangle where I know the length of one side, which is 4c. I know the length of the other side, which is a. I know the angle between them, which is alpha, and that will allow me to use the law of cosines to find h. H squared is equal to this expression, which I've written out, and that allows me to solve for h. And when I do that, I get 5.00 and then some extra digits. So something almost exactly 5. That makes me think of a 3, 4, 5 triangle, but I don't know that for sure. But now I need to find its direction. And so what I'd really like is this angle here, which I'll call delta, that will tell me where it is counterclockwise from the positive x-axis. To find that, I could find this interior angle here, call that beta, because then beta minus this angle, which is just 180, minus alpha minus theta minus phi, and minus this angle, which is theta, will give me delta. I need to find this angle beta. And I first did that using the law of sines again. So I had sine of beta divided by 12 is equal to sine alpha divided by 5. I get beta is equal to 77.07, another 77-degree angle. And this one, I'm just not really sure whether that's 77 or 103. I'm less sure of my angles in this case. So I went ahead and just checked it using the law of cosines. Now, when you solve for this, you get cosine beta is equal to a negative 0.2249. 144 minus this amount is still a positive number, so when you divide by negative 5 times this, you get negative 0.22. And that turns out, beta then turns out to be 103 degrees. It's the other one. I would like to point out that if you forget this minus sign, you are going to get 77.07. You're going to get the other value from the law of sines if you get this sign wrong. So that's a particularly troublesome error you might find, so you have to be careful about your signs. But now I can calculate delta, because delta is beta, which is 103, minus theta, which is 14. That's this theta, so here's beta, minus theta, minus this angle, which is 180 minus 50.9 minus 77.0, some digits there, which gives me an angle of 36.9 degrees. And that is a 3-4-5 triangle, so my final result H is 5.00, 36.9 degrees counterclockwise from positive x. At this point, I would want to check that out. Calculate a couple of these other angles to make sure this is all consistent. And I say that because when I first wrote the solution to this, I got the wrong answer. I did not get 36.9 degrees. I got something like 11 degrees, and which said, so it's not a 3-4-5 triangle. That's kind of weird. And so then I went and checked my angles, calculated some more to make sure that all my angles of my triangles added up to 180 degrees, and they didn't. Okay, I had made an error. And I went back through my calculation, and remember this minus sign? I didn't have it there. I got that wrong, and I had beta is equal to 77.07, which I thought, oh, that's got to be right. And I went ahead and calculated it, and I got the wrong answer. So then when I went back and found that I missed that minus sign, I got the right answer, and then I got it. So when you're done with a long calculation like this, make sure that you go back, calculate other things that you can calculate to check to see if your answer makes sense.